Cool. Yeah. So let's get it on. Gemma, do you want to take over?
Yeah, it's my pleasure. Okay, so let's start. I will share my screen and please tell me when you see it.
Yes.
Okay, nice. I will turn off my camera, so just 1 second. Okay, so hello everyone. Today we are going to talk about Bolt, visual scripting. It's a visual scripting tool that has been acquired by Unity earlier this year and is now officially included in all Unity plans. You can have it at no cost. That means that you can download it today and start making game without having to write any line of code. It lets you create visual graphs instead of written scripts to create game logic. So it's a node-based graph. These are node-based graph that you can have for both non-programmer and programmers alike. So if you are no programmer, you can still use it. You can use it on its own or in conjunction with regular scripts, whichever suits your work best. It also supports every class and struct type, and it includes API for advanced tasks, custom nodes, and even more. So if you are using Unity 2018 or above, you can create either portions or entire games using Bolt. It's also an excellent tool for rapid prototyping and testing. And if you are a beginner and you just need to understand the basic of the coding and scripting, you can use Bolt to do just that. So how to start with Bolt? First, to get it, you have to go on the asset store, download the package, and then import it into your project. Then, using the Bolt setup wizard, you can complete the setup in your project, then you're ready to go. We are going to use the Bolt setup wizard in our demo here. So let's start with our demo. Once you download and import Bolt, you will find it under Tools, and you can use the setup wizard to choose the naming scheme first. So you can have it either on human naming or programmer naming. As you can see, the difference is here, for example, it's list of game objects, and here it's list game object as you can write it in the with C#. So let's choose the human naming for today. Okay, this, of course, it doesn't work. Okay, let's try it again. Awesome. Great. I'm sorry for that. I just tried it before this session and it worked just fine. Maybe we should update it. Okay. So let's go back to the presentation and I will explain the setup because for now I think it's done. As you can see, you choose the naming scheme, then in the assembly options, you add the assembly that you want. And then in the last one is choosing the type. So if you have a custom types, for example, you can add your custom type. Okay, let's go back to our demo now. The demo today, all the logic in this demo have been developed using Bolt, but it's missing. Some components are missing, and today we are going to add these components to make this game work. Let's try the demo. As you can see, we have the character that is animated. This is the idle animation. We also have the guard. The character needs to interact with the guard and then gets a pass to go through the laser door in here. If we click on the arrows to move our character, we can't. I don't know if you are hearing the clicking, but nothing happens. And that's because our character doesn't have the logic to move in the scene. So we are going to start with that. Let's select our player in the game. Oh, sorry. To use Bolt, we need to open a few additional windows in the editor. we are going to find them under Window. The first one will be the graph, which is the visual representation of the logic that we will be using. It will contain all the nodes that control the logic. The second one is the graph inspector, which will allow us to check what each node does, what's in the graph. And the third one will be the variables. The variables are the variables that are either in the app, so they are shared across all the scenes. In this scene, they are shared across all the game object, but only in that particular scene. They can be saved as player prefs, for example, or they can be on a game object, so they are shared across all the flow machines that are on this game object or in the graph. We will use them all later in the demo. So like we said, we first are going to start with the player. This player have the animator and a character controller. So to make it move, we simply need to add a simple move, a character controller dot simple move method. We are going to call it in the graph. And to do that, we are going to add a flow machine, a machine component to our player. We are going to find it under Bolt. And we can choose between either a flow machine or a state machine. The difference here, we will see the difference later, but for now we are going to choose a flow machine. A flow machine will allow us to execute the logic that exists in a flow graph. When we add the component of the flow machine, the variable component will be added automatically. Now, to execute the logic that is in a flow graph, we need to choose between either the source could be a macro or an embed. The macro is a reusable graph that can be reused on different machine and on different game objects, whereas the embed can only be used on the game object that is being created on. So we are going to use a macro, and we can either choose between a list of macros that we have, or we can create a new one. So let's create our new macro. We will put it under Bolt macro folder, and we will call it third person controller. Now that the macro is being created, we will see that the graph is now called flow graph because we are seeing a flow graph in here. And two event units have been created by default, the start and the update. When we click on the start, we will see in the graph inspector what this unit does exactly. This unit is called the first time a machine is enabled before any update method. And this one is called every frame. Right now we are going to move our character, so we don't need the start unit. We will just keep the update unit for later. And we are going to create another unit to look for the simple move method. We will, we just right click anywhere in the graph. We add a unit, and then we can either look by category. Like for example, here, if I click on the player, I remind you that the player is the game object that we are working on. If we click on the player, we will see all the components that are present on the player, the game object, the transform, the animator, the character controller, and the flow machine. And because we want to use the character controller simple move, we just click on character controller and look for simple move. We can do that, or we can do the same by looking for simple move, and it will return us all the units that contain the words that we've been using in the search bar. So let's close the fuzzy finder here and concentrate on the simple move. Right now, the simple move here, we can read about it in the graph inspector. So it moves the character with a speed. The inputs are invoke flow. This is this arrow, the arrow port allows you to connect it to another unit. So it will happen after the other unit. It also contains the target, which is where the character controller is. It's now set on self because it will apply on itself. And it also has the speed, which is a vector 3 that we will add. So let's try it. Let's just add a literal vector 3. As you can see, once we click on drag anywhere in the graph, sorry, let's not do that. So if we click and drag from the speed, we will see that the units that will appear in the fuzzy finder have all an output that can be a vector 3 and that can be an input to that unit. So let's just write a literal vector 3. Let's add -1 to the Z. Let's link it to the update event. Now what will happen is that the update event will be called every frame. Then it will execute the simple move. And the simple move will get this vector literal that we've created. So if we click on play, we will see that our character will continue moving forward. And you can see that the flow, you can witness the flow in the flow graph here. So now we are going to do it properly. What that means is that we need to create a variable. Let's create it on the game object so we can use it later on other flow graphs. We will call it motion speed. And we will define that it's a vector 3. Now that this is created, we can just drag and drop it in the flow graph, and we will get a unit to get the variable. So this output would go to speed. Now we are going to set the motion speed because for now it's just a 0. It has the value 0, and we need to set it before moving the character. So how to set it? To set the movement, we will need to have the input from the horizontal axis and the vertical axis. So let's look for that unit. Let's look for get axis. This will give us input.getAxis. This is the one that we need. And put it to horizontal. And let's just duplicate it, Control D. It will duplicate it and modify this to vertical. Now that this is done, we will get those values, the result, which will be a float, and we will create a vector with it. So let's look in the vector 3 category. And then for create a vector, let's look for create a vector. I don't know. Yeah, for new vector. The horizontal goes to X and the vertical goes to Z. And then we will set, what is the name of the variable? It's motion speed. We will set the motion speed. So as you can see, I just wrote set and motion speed. And now I can set my motion speed with this vector. Okay, so now this is set, but either you can see it in the graph inspector, this unit is never entered, or you can see it when you click anywhere in the flow graph. Neither of these units is selected, is entered. So let's take care of this. We are going to set the variable each frame. Then once it's set, we are going to move the character following the axis that we have. So the thing is, we don't need to get the variable with a unit. We can click and drag the output of setting the variable to the speed, and it will be the same. We can do that if, for example, we have a complex graph and we need some clarity, but for now we will remove it and we will try it to see what happens. So now, as you can see, all of these are blue, which means that all of them are linked and are active. So what we're going to do is I'm going to click on my keyboard on the up button, up arrow, and on the bottom arrow. The thing is here, my character is moving opposite to what I want exactly. So what I'm going to do is that I'm going to add another node that I will call, another node to multiply. To multiply my vector by a literal float, which will be -1. Then the output would go to setting the variable. And what will happen now, and we will see it directly in the flow graph, is that I don't know if you can see the outputs. I don't know if you can see the values, but here it's 0. And once I click on the forward arrow, sorry, here is 0. And when I click on the forward arrow, this will be 1. It will create a vector with 1 on the Z, but then the variable that will be motion speed will have -1 because it will be multiplied. So yeah, you can see them directly in your graph. Awesome. Now our character is moving just fine, but as you can witness it, it doesn't have any animation to move forward or backward or to change the rotation. To remedy that, we can either add more nodes to the same graph, and because it's already been dealt with elsewhere, I already have a player animation flow graph. What I can do to add it to my current graph is I'm going back to the player, and I'm going to drag and drop the player animation directly in the graph, and it will create a super unit. A super unit, the super unit is nested graph within the transition. We can add a logic to trigger this transition. We can have a super unit without needing a transition, but if we want, we can add an input and an output flow. For now, the super unit can be by itself and doesn't need any flow input or output because it already has the fixed update. So once we've added it to the player graph, we just need to click on play. And then, as you can see, the animation and the rotation is taken care of by this super unit. Let's double click on it to check what it's inside. Here in the fixed update, it will check if the motion speed is not equal to 0. If it's not equal to 0, then our character is moving. And if it's moving, it will change the animation to go forward. So let's try it again and see what happens. Once I click on the button to move the character, it will move it. So the thing here is, I don't know if you've seen it or not, but I am using the motion speed, which is the variable that is in this graph. The variable that I'm using in this graph, and I put it on the object to use it on other graphs. So the other thing that I can do is let's remove it from here and create another machine, a flow machine. I can also add it directly in another flow machine, player animation, and it will work the same. Let's try it. The cool thing with Bolt is that some of the changes can be kept even when we are changing it when we are on play mode. So if I go out of play mode and then I click on the player again, I will see that my nested, my super state that I removed when I was on the play mode is removed even when I go out of play mode. So
I was actually going to ask this question, Shema.
Yeah.
You anticipated me. So what is it exactly that you can change at runtime?
So what you can change at runtime is you can add units. Let's try it. I think the only thing that you can change when you are at runtime is adding variables and using these variables. But other than that, so for example, if I add, let's say game object, and I don't know, game object, no. Let's do something that works. Okay, so I will remove the multiplier and link this directly here. Let's try this and go out of play mode. And as you can see, my change stayed even when I got out of play mode. But if I create a new variable and I use it, let's go in play mode and create an int. Then drag and drop it. I think this will not stay when I go out of play mode. Yeah. So as you can see, I have the unit here, but I don't have the variable in the variable graph variables.
That makes sense, and it reminds me of you know, how you can edit assets but not scripts on game objects, right? Like the bolt flow graph is probably a scriptable object, so you can edit it just the same way as you would edit like a post-processing profile or an animator state machine, because they're all assets. So it makes sense.
Yeah,
okay,
exactly.
Thanks. It was a curiosity.
Yeah. Okay, so now that we have our character that is moving, let's interact with the guard. If we click on play again, and then, oh yeah, okay. I think I removed the second machine, flow machine. So let's add it again and play the game. Now I'm moving and I stop in front of the guard. Let's interact with them. Welcome to ATC Corp. We're close to 2 guests today. Next. The player is surprised then, but if you have a key card, you can scan it and at the gate. Okay, thank you. Now what should happen is that my character here needs to have an animation to grab the passcode in front of the guard. So let's check this. In the animator, let's go to the parameters. I have a trigger that's called grab. Once I click on it, please focus on the player so you don't miss it. So once I click on grab, you will see that the character will play this animation. Okay, so let's do this. Let's make it reach for the passcode once the dialogue is done. To do that, we are going to switch from the player that we were working on until now to the canvas. In the canvas here, I am using an embed because for now, I'm using an embed because I need multiple I need multiple scene variables, and to do that, we need to know that the flow graph that we are using will not be used in other scenes. So we are going to use the embed in here. Great, let's click on it. Once we click on the canvas, as you can see, the flow graph will change and will show us the embed that we have. Sorry, once we have, yeah, okay. As you can see, it's very complex. It has a lot of things. It starts the dialogue, it shows lines, it ends dialogues. And to get your flow to be more comprehensible, you can create, as you can see, some boxes to group the nodes that you are using. So for example, if I go here, I know that this start dialogue has an animation, animate and activate the action panel. Then it animates and opens the dialog, and I don't know, maybe I want to add a comment. So for here, I say this is a comment for another person that will be using the same graph as me. I can also, in this case, change the color of the grouping. So for example, here I put it to red to show you that this is missing. I have a trigger for end dialog, but I don't have the trigger for the get pass and the half pass events that are custom events that can be called from one flow graph to another. So let's do this. Let's start with the get pass event. The get pass event needs to be on the player. So let's go back to the player, then create a custom event. Let's look for custom and event. We will call it get pass. This means that when we will call this event, we need to do something, and to do something means to click and drag the arrow part to look for the animator. And what we are going to do is that we are going to set the trigger. So let's look for set trigger, where we see that we have the animator.set trigger. It's set to self, and we know that our animator is in the same game object and that we are working on. So we don't need to change this, and we are going to put the name grab because the parameter, the trigger is called grab. Now let's go back to the canvas, and what we are going to do is that when the dialog ends, we are going to also trigger another custom event. We are going to trigger another custom event that's called get pass. And this event is not on this game object, so it's not on self, but it's on another game object that we can find in the variables that we have in the object, that is the player game object. So let's get the player game object and link it to the object that has the event. Now let's play it and try it. First, we are going to try it to look at the game. Then we are going to look at the flow graph because we need to see what happens in the flow graph at the same time. So let's look at the game window first. Let's interact with the character. Once the interaction is done, we have the animation here. And if we replay it again, let's replay the scene. Sorry, because I reloaded the scene, I need to click again on the canvas. Let's walk to the guard, interact with them. Then look at what happens in the flow graph. We are going to trigger the custom event that will be on the player, and that will set the trigger of the animator to grab. Okay, nice. Now we have our passcode, our key pass. We need to go to the door and scan it. Unfortunately, I didn't implement the scan yet, so we will do it together. And to do so, we are going to use a state machine. We are going to use a state graph, sorry. So what is the difference between a state graph and a flow graph? The flow graph, you connect individual actions and values in a certain order. That order of execution is what we call the flow. That's why we call it flow graph. Whereas the state, you create different states and a transition between them. Each state acts as a little program. So each state will be a flow graph. Let's do that. We will be working on the security laser. it already contains a flow graph, so we are going to create a new machine, which will be a state machine. In this state machine that we will be creating, let's create it. We will call it laser state machine. Once we create it, we will see that we have a state node that have been created. This one, because it's green, it will be the first one to be executed. We can toggle start. So for example, here I say this is the start state or not. Right now, we are going to say this is the start state. We are going to change the name to, oh, sorry. I will explain what are the states that the door will be in. So the door will be either locked, so the lasers will be red, or active. So when a character comes near the door, it will become orange, or safe. Safe means that the lasers will be green and we can go through it without triggering without triggering the reload scene, because for now it reloads the scene. So let's create these three states. First one will be the locked state. The second one that we will create will be the active state. And the third one will be the locked, the safe state. This is the last one. Let's add. Okay. So now we are going to check what each state is. If we double click on the locked state, it will open a flow graph. As you can see here, it changed from state graph, if we double click it, to flow graph. It will contain the on-enter state node event unit, the update, and the on-exit. We only need the first one. We only need the on-enter state. When we enter this state, we want our laser door, we want our material to have the color red. So we will set the color of the material. Let's look for material and then set color. We want to set the color of our material to red. The material is laser wall. And we are going to change the color. Now this is easy. This is what already exists. So let's copy it. Go back to our security laser, the state graph. Double click on the active state. Remove all of this and paste it, because we can do it. We can do that. Just change the color to orange. So when it's active, we will have the orange color. And then the last one, let's just copy it again. And the last one will be green. Awesome, we have our three states. Now we need to create a transition between each state. To do that, right click on one of the states, then make transition and make the transition to the state that you want to make the transition to. Here we have the active state. And this will create a transition graph. We double click on it. It has a triggered transition. This will trigger the transition to the other state. So what will trigger the transition between the locked state and the active state? The character needs to be inside the area of the door. So we have a box collider here that is a trigger. Once the player will be in the area, and so on trigger enter, we need to change the color. Let's do exactly that. we will look for on trigger enter. Then we need also to check if the collider has a tag of player. So if the player is the one who collided with the trigger here. So on trigger enter, and let's look for compare tag. This will create a unit to compare the tag with something that we can either create as an entry, so string return, or write it directly here. So let's compare it to player, of course, when it enters. And then if it's true, so we need to create a branch. If the comparison is true, it will go to trigger transition. If it's not, it does nothing, but we can create something here. So yeah, the branch is like having an if. Okay, now let's try this without going further. Our character will walk. Okay, here we don't need to interact with the guard. We just need to be in the area of the door. So as you can see, the door is now orange, but when we go out of the area, it doesn't turn back to red. And that's because we don't have an on-trigger exit. So let's create it. We are still in play mode, so let's try it. Let's see if this still works or not. So make a transition to the locked state, open the transition, create a unit with on-trigger exit. We will do the comparison again. So let's just copy and paste it to not waste time. Yeah, nice. Oh, sorry. Oh, yeah, I wasted more time. Okay, so we are going to check it, and then if it's the same tag as player, it will go back. Let's try it without going out of the player mode. Yep, it's working. We enter, then we exit the other state. Let's look at it from the state graph. As you can see here, this is the active state. Now this is the active state, and now it goes back. Awesome. We know this is working, so let's take care of the last state, which is the safe state. Here we just need our character, here we just need the door to turn green when we click on a button. Let's say we click on the enter button. So we will make a transition to the safe state. We will open the transition graph. We will add a unit. Let's look for input keyboard. Oh, let's look for keyboard input. Yeah. So on keyboard input, let's say it's okay. Let's put it at space. Once it's down, we can trigger the transition to the safe state. Now we will test everything. We're going to interact with the character. Get the pass, go to the door. It changed to orange, and then click on space, and it should change to green. Awesome. This is a very sneak peek to what you can do with Bolt. If you want to have more information about it, I have some links that I can share with you in the chat. You can find the Bolt documentation where all the Bolt templates are on the asset store, or some Bolt samples that are in the GitHub. Thank you very much for following. And if you have any questions, I'll turn my my camera again. Just 1 second. Okay, yeah.
Thanks a lot for a great talk. I think I'm going to change all my state machines now to yeah. Are there any questions? Please go ahead.
I have one super tiny question.
Yeah.
And because you were mentioning this that some parts of the flows or the state machines get saved.
Yeah.
This is kind of like depending on when they are bounded. So if they are embedded, they get serialized or not because they are in the scene, and if they are somewhere externally, it's like with the prefabs or something like that, or.
I don't know exactly. I can't tell you exactly why some of them are saved or not, but I think that Chiro said that it's because is a script.
Sorry, can you repeat the question? I was distracted.
So the question is if it has something to do when the flow is embedded or is saved like outside in the project to decide when something gets serialized on play mode.
Could be. I'm not an expert on Bolt. Shema, maybe you can open the demo again and just make a quick test so we can we can know in real time. But
I mean, if it plays the same, like for example the prefabs, you know, sometimes when you are editing the prefabs just because they are in the project, they get automatically serialized. But when they get in the scene, just in the moment you pause the scene or you stop it, then
yeah, because as you say, like the prefab itself is an object which lives on disk, right? It's a different asset, and when you press save, the changes that you made get saved on disk, and that's why it's called actually save and not apply, right? So save means that you're actually saving to the asset, while the scene is like it's another asset, of course. But when you have a prefab in the scene, that's not the prefab, that's an instance of the prefab, right? So all the changes on that instance are saved within the scene. And the key thing is that when you press play, Unity kind of like spins a version of that file, right? Which lives in memory. And that's the one that you see in the inspector. And that's the one that you can modify. And also it's the one that gets modified by your gameplay. So for example, if an object moves, that version that is spun out is the one that gets modified. So if you make changes to what you would call a prefab, but it's not a prefab anymore, right? It's just a game object in memory. That change does not survive when you stop, because that's just in the RAM basically.
Exactly, but that's why I meant if it was playing the same way the flows when they are in bed. So in the
let's
scene,
check. Let's see. Shema, can you create a how's it called, a flow machine, right?
Yeah.
When there is like embed.
Sorry.
When it is like embedded in a game object, and
okay,
then,
so we have the embed in the canvas. Okay.
Mm-hmm. And then just press play and make a change to it and see if, out of curiosity, if it survives.
Okay.
Entering and exiting play mode.
I think there isn't a difference between both, but let's try it. Okay, let's go out of the play mode. Oh no, it doesn't. Doesn't keep.
So I guess it behaves exactly as if you were like a prefab instance.
That's perfect. We know it's consistent.
Yeah, exactly. Yeah, true.
Yeah.
Definitely. It would be weird if you would say.
Yeah, exactly. If it's something
to the asset. Mm-hmm. Yeah. I guess the point here is that, and actually, another curiosity that I would have is if this whole graph is in the scene, right? Like
yeah. So actually, because I'm using Collab, I know that if I change anything in the embed, the change will be on the scene. Mm-hmm. So I will need to commit the scene again. I will know that the scene have been modified.
Which makes a lot of sense. Yeah.
Yeah.
So basically, this whole graph is just values in that component.
Yeah.
It's just
I guess
it
so.
lives within that component. Yeah. Okay. Cool.
Yeah.
It's actually a
Another
very powerful
concept.
system, Bolt. It looks like a toy. I think the icons are very misleading.
Yeah.
The colors, it looks like very playful. I remember watching it compared to Playmaker, because Playmaker was very popular a few years ago, and then Bolt came out, and it looked like the toy version, but it's not.
Yeah. It's really powerful, and I like it so much because at one point I had the QWERTY keyboard, and I wasn't used to it. So instead of writing code and like getting some code misspelled and things like that, I just needed to drag and drop some nodes, and it was really nice. It's really helpful, and yeah, it creates a whole game with just nodes.
You must know that Shema is obsessed with AZERTY keyboards.
Yeah, I am.
Like every French speaker person.
Yep.
She requested like a custom computer with an AZERTY. Sorry, we're eating up time, but like there's the other
No
talk.
problem, no problem.
Oh, okay. So are the questions later after the other talk?
No, if there are more questions,
I think it
please
makes
go
sense
ahead.
to, yeah, I think
Yeah.
it makes sense to do it instantly. So I have some questions, but I want to please the audience to come forward if they have some questions. If not, I will.
Yes, please. Even drop it in the chat.
Ask
Okay.
in voice.
Okay, my first question is like, you showed us the dialogue system. Is this kind of, do I have to hardwire all the steps in the dialogue, or can I make some loops and get the questions and answers from a database or a scriptable object or stuff like that?
It depends on what you want. This one
Okay.
I just created. It's like creating a script. I don't know. Are you still seeing my screen? Yeah, I think
Yes.
so. So if I go, for example, to the dialog controller in here, because before getting it as embed in the canvas, I created a flow, a macro. So if I go here, so what happens is that it will start the dialogue. It will animate and disactivate the action panel, the one with talk that exists on the guard when I interact with them. Then it will animate and open the dialogue.
Mm-hmm.
And then it will call a custom event that's called showline. And I could just link this to this line, but I didn't want to have a lot of flows and arrows. So I just created a custom event in the same flow to show the line. So this one, show the line, will check the list of dialogue that I got from the resources. I just created a CSV file with the whole dialogue, and in another, let me show it. So here, this is the dialogue setter. So in here, no, sorry, not this one. So in another flow graph, which is called Parse Dialog file here, it will get the dialogue loaded from resources and then parse it to, at the end, fill a list of laser dot dialog. This is a list of dialog. Dialog is a custom class that I've created. So as I said, you just create your own logic, and you just need to implement it later.
Mm-hmm. So I think this also answers my second question, the interface back to script code. I think
Sorry?
that's exactly that. And how can I interface from board back to script code? And I think it's just that, or what you presented with the list.
Yeah. I have this, let me show it. I have this slide in here. So this one is very nice to compare between a script and a graph. Mm-hmm. So if you compare here, like for example, player game object, find game object with tag, it's in here, find game object with tag, then set the variable, use a for loop here to debug something. So yeah, it's nice.
Nice. Nice. So my third question is like, how can I compare Bolt to C#'s writing or going from I2L CPP, IL to CPP? How is the performance impacting on, let's say, mobile devices or on the PC? I guess on the PC is not that much an issue, but maybe on mobile devices. So when do I reach a certain limit where I should more concern about writing in code instead of using Bolt, or when it's better to use Bolt instead of code?
I'm not sure about this one. I have to get back to you later because yeah, I didn't think about the performance yet, but I don't think it impacts a lot. Yeah, but I have to get back to you with the answer on that later.
Okay.
I think it's the usual question of, like.
Yeah, always. These
it's
programmers.
A matter of, no, I mean, it's a matter of scale, right? Like,
yeah, for sure.
You can totally use it on mobile, but like how many nodes, how many graphs at the same time depends on device. So you need to, it's one of those things that you have to test.
Yeah. Understand.
Hard to answer with one definitive answer, and then somebody makes a whole game out of it. And it's like the Unity guy told me it worked. It does, but.
I have one question also. Do you guys know any kind of, like, looking ahead, any plan with ECS and Bolt, like if it's something in the roadmap, or because right now I guess since it's Bolt, the Bolt that was already in the store is just playing with mono behaviors, but how, if it's something planned to be integrated with ECS, or what is ahead?
Yeah,
I think so. For what I know, I don't have a very 100% clear question on that, but from what I know, the plan is to move ahead with Bolt for now and make it more integrated into the engine. So I think you saw some, basically Bolt as it is now, it still feels a little bit like an external plugin. So we want to make it more integrated into the engine in all senses, like UI-wise, but also functionality-wise, workflow. And that's going to serve the games made with game objects, right? For ECS, we still have our own solution that we were developing, and we are still developing it. The key point there is that they work in pretty different ways because ECS, you know about ECS, right? Like you used it. So the way you do things there is you don't attach that to one object, but you do queries, right? So they're so fundamentally different, then I don't think Bolt is going to evolve and support ECS. I think we're going to have these two different systems. But it's also like a conversation for a bit further in the future, because ECS is still not like at 1.0 or however you want to call it. Like, so it's a bit far still. And that's why we decided that Bolt, it made sense to actually introduce a game object-based visual scripting solution rather than wait for the ECS one to be ready. And then the point was like, why make a new one? Let's just acquire, a solid one. So we acquired Bolt. So again, ECS is still a bit far in the future. Some people, some students are even making games, professional games these days, but as a whole complete, like you can make anything with ECS kind of thing, is a bit far still.
Yeah, I mean, for us also in the companies in general, they don't let us touch the stuff that is in preview. So yeah, but
ECS is very much in preview. Yeah. And the visual scripting for ECS is even, I think, is just experimental for now. Do you know the difference in this different states, like what experimental means and preview means?
Not ready for production, for sure.
No, but seriously, do you know the difference? There is a difference.
It would be nice to.
With I don't know.
Shema, do you know?
I think so.
Everyone has a clue how it.
Yeah. So I think
if
that
you have insights, it would be awesome.
I think that experimental is still, we are still experimenting, so the flow can change from one day to another, while in preview, we know that the flow works, but we need some feedback. So still in preview, it still has some bugs, but it's, we need to, people to try it, to get their feedback and to fix them to go on production. I think that's the case.
I would say even more. I mean, experimental, as you say, like we are experimenting in the sense that like the thing might never come to reality. Like, yeah, so when something is in the experimental stage, it means that we are still figuring out even the shape that it should have. Yeah. So, you know, we might make it as an editor window. Tomorrow it might be, I don't know, an external product, you know, or something like that, or it might work completely differently, or it might never exist. That's what the experimental stage means. And I think there were some features that were kind of like pioneered in experimental, and then they disappeared, and then they came back in a different shape. And I don't remember exactly a good example of this now. But experimental things, you would see them on the forums, for example. So we really want to release them to a very, very small audience. And the forum is not a small audience, but the people who are on the forum are the, you know, there's a few expert users, and it's definitely different than releasing something, you know, through the blog or through YouTube. So, and then preview is when we know we want to work on this feature, and we want to know the feature is going to come out. And that's the shape that it has. The only thing with preview is that maybe the file format, the how do you call it, the serialization state is going to be different, which means that basically if you work on something and you upgrade that package or that feature, which is in preview state, your work might break. So the feature will still have, you know, like the same shape, and it will still kind of like work the same. So if you learn how to use it, you're going to know how to use the upgrade. But once something is in preview state, it doesn't guarantee that you can upgrade your project smoothly. And then once it's out of preview, it means that we need to guarantee that you can upgrade your work. So when it's out of preview, it means that you can kind of like start producing assets, because then when you upgrade that feature, bugs aside, we try to make sure that you can upgrade your work. That's kind of like the differentiator between the three states.
Thanks for elaborating. I mean, we had some clue about that, because we worked with AR interface and then later with AR Foundation, and we had a lot of API changes.
It's super clear. The other distinction with preview and not is when you're working, for example, in an LTS version. So imagine that like 19.4 LTS is out now. Mm-hmm. If a package is out for 19.4 and is in preview in 19.4, it means that if we fix some crucial bug tomorrow, like, you know, at the end of this year, it doesn't get backported to 19.4. But if the package was out of preview when 19.4 came out, then it's kind of like part of the LTS. And so you also receive like all the fixes. Mm-hmm. Sorry, I'm stealing a lot of time. I mean, I guess.
Don't worry. The one that has to do the presentation is me. It's not that fancy anyway.
Okay, but the others have to, you know, maybe some people are here, they're like, I don't want to hear about Unity.
I have one last very out of curiosity question is like, you choose Bolt as a node-based scripting system. Why not any of the others? I think there are 3 or 4 other good tools there. Is this an internal process, or it's just like, take this? Do you know how this process works, or?
No, I don't know. There was some kind of strategic decision behind it. I even saw like a matrix of like the kind of like the advantages, the pros and cons of the different systems, and you know, they just figured that like that was the best tool to integrate. It could be for a variety of things. Like I think that there might be tools out there which are, you know, maybe either too simple or too too like how can I say all-encompassing, you know, they're doing too many things, and then the UI is a bit overloaded, and then they chose Bolt as like kind of like this middle ground, which is like it does a lot of things, still is also customizable, and that hits that kind of like that tier. But I'm not sure about the exact reasons.
Cool. Yeah, thanks a lot. Also,
thank you.
No worries.
Elaborating a little bit on the insights and all the what preview and experimental means. I think it really can be helpful to know it more than just